Here's conditional probability with multiple outcomes. Now, this one takes the longest. It's not necessarily difficult, but it is tedious and you have to take your time. If you've watched any of my videos before, you can tell my voice is changing because I'm trying to go a little slower here. So in a question like this, you're generally given 3 probabilities and then eventually asked for something. And those 3 probabilities turn into 6 probabilities because you have to find the complement. So walking through this, it says we want to see how good a new flu test is among individuals. Assume currently 5% of the population has the flu. So the probability you have the flu is going to be 0.05. So the probability that you don't have the flu, so not flu, is going to be the complement 0.95. That is one combination. Now, the probability that the flu test correctly identifies someone with the flu with a positive result is 0.97. That is a conditional probability. That's the probability that you get a POS positive result given you have the flu. That's what you want. You want to get a positive test if you have the flu, and that's going to be 0.97. But occasionally, you might not get a positive test. So the probability of not getting a positive test, given you have the flu, that means it was misdiagnosed, is 0.03. That's the complement. And that's the next combination, the next pair. And the probability that the flu test correctly identifies when someone does not have the flu with a negative result is 90%. So the probability that you don't have the flu, so given you don't have the flu and you get a negative result, which means not positive, okay? Not positive, given that you do not have the flu. This is the complement, basically, is going to be 0.90. So given you do not have the flu, that's conditional probability, and the test says you're not positive is 0.90. So that means the probability that it actually gives you a positive result, given you do not have the flu, is going to be 0.10. Go back through, make sure you followed all that, and these are the 6 probabilities that you're presented with. Now, the final question says, find the probability that someone has the flu and the test gives you a positive result. Well, to put all these probabilities together, you have to know the formula for given probability, for conditional probability. The rule was the probability of A given B is equal to the probability of A and B divided by the probability of B. So basically, you're going to multiply that denominator over and say the probability of A and B is going to equal the probability of A given B times the probability of B. Again, that vertical line is the given. We're not done. What is A and B in this case? Well, it's flu and positive result. But you have to be careful here because if you write it in as flu and positive, we don't have flu given positive. And we don't have the probability of positive. We have none of those over here. So what do? The order can be switched. That's what makes this all a very challenging question. So saying find the probability you have the flu and you get a positive result is the same thing as saying find the probability you get a positive result and you have the flu. And that is the last piece to this puzzle to finish solving. So the probability of positive and the flu will equal the probability of positive result given you have the flu times the probability of getting or having the flu. So what are those 2 probabilities? Well, that last one is right here, and that one before it is right here. So you're going to have essentially 0.97 times 0.05 to give you a final answer of 0.0485. This will take practice, but you'll find the patterns, take your time, and that's how you deal with conditional probability in a paragraph form when you have multiple outcomes. Again, you have a lot of setting up to do before you can jump to the answer. That's what makes this a challenging problem. Good luck.